All right, for the next little bit, we're going to be talking about energy, and we are going to talk specifically about kinetic energy, which is the energy of motion, and we'll be talking about gravitational potential energy. There's several different types of potential energy. There's gravitational potential energy, there's chemical potential energy, there's elastic potential energy, but we're going to limit our studies to potential, gravitational potential energy. So kinetic energy, again, is the energy of motion, and usually kinetic energy is gained from transforming stored energy, some sort of potential energy. Like if you take a rubber band and stretch it, you give it elastic potential energy, and then when you let it go, that elastic potential energy gets transformed into the kinetic energy of the rubber band flying through the room. If you take something and sit it at the top of a ramp, that's giving it gravitational potential energy, and then when you let it roll down the ramp, the gravitational potential energy turns into the kinetic energy of the rolling object, or sliding, or whatever it's doing down the ramp. So, in order to change an object's energy, and this says it's kinetic energy, but really the same holds true for any kind of potential energy. In order to change its kinetic or potential energy, work has to be done on an object. So when you, for example, when you stretch a rubber band, you're changing its elastic potential energy by doing work on the rubber band. When you set something at the top of a ramp, you have to put it up there to begin with. So you had to do work on it to lift it up to the top of the ramp to begin with. Kinetic energy is directly proportional to both the mass and velocity of an object. So if it's got more mass, it's going to have more kinetic energy. If it's got more speed, it's going to have more kinetic energy. Now, of the two, as we can see here in this equation, the velocity makes more of a difference, because in this equation, the velocity gets squared. A lot of times I will rewrite this equation as mv squared over 2 instead of multiplying by 1/2. Dividing by 2 is the same thing. But if you double the mass of an object, it's going to double the kinetic energy. But if you double the speed, velocity of the object, because the velocity gets squared in the equation, 2 squared is going to be 4. It's going to have 4 times as much kinetic energy if you double the velocity. All right, so potential energy, and again, when we're talking about potential energy, we're going to be specifically talking about gravitational potential energy. Any kind of potential energy is stored energy. Gravitational potential energy is energy that's stored in an object because of its position above a reference level. Chemical potential energy would be the energy that's stored in the chemical bonds of a compound. Elastic potential energy is the energy that's stored in something that's being stretched or compressed. So again, we're going to be looking specifically at gravitational potential energy. And that, again, is directly proportional to the object's weight, which is mass times gravity, and its vertical position above or below a reference level. So the reference level, kind of like reference point that we talked about back in the day when we were doing velocity and displacement. Reference level is something that we get to choose. Okay? So height can be measured as either above or below the reference level, depending on what we choose to be the reference level. Again, because an object's weight is its mass times gravity, we could rewrite this equation as PE equals Fg times h. The board's going kind of crazy here and making these things bend a little bit. There we go. So we could rewrite the equation as potential energy equals weight times height. And some books would have a G in front of the PE to show that we're talking about gravitational potential energy. All right, so this reference level business. Let's say here's the floor and here's a table. Maybe the table doesn't overhang quite so much. And we've got an object on the table. If we consider the height of the table to be our reference level, then when the object is sitting on the table, it has zero height above the reference level. And so its potential energy at this point would be zero. Energy, because it takes work to change an object's energy, energy and work are measured in the same unit, joules. So if the object is sitting on the table and we choose the tabletop to be the reference level, then right there the object has zero potential energy. If we lift that object up to some height above the reference level, the table, well, now it has a potential energy equal to the object's weight, or mass times gravity, and the height that it is above the table. If instead we knocked the object off the table onto the floor, well, now it's got some negative height. So the potential energy is going to be equal to its mass times gravity, and now the height is negative, so the potential energy is negative. Kinetic energy, by the way, can never be negative because the only thing that could be negative in that equation is velocity, but velocity gets squared. So when you square the velocity, if it's got a negative velocity, then squaring it gets rid of the negative sign. So kinetic energy is always positive, but potential energy can be negative if the object is below the reference level. Okay? If we put the object back on the table, but then decided that the floor was our reference level, then when the object's sitting on the table, it still has potential energy. And now the height is no longer negative. Okay? If we lifted the object up to this other height, that would just give it even more potential energy because now the height is even larger. I'll draw a bigger H to show that it's a larger height. I'll make the P and the E bigger also because now it has more potential energy. All right, I think you get the idea there. And this slide just kind of talks about all that stuff. We can choose what the reference level is. And so potential energy can be positive or negative depending on where the reference level is and whether the object is either above or below that reference level. This last part here we didn't talk about yet. Objects, most of the time, can have kinetic and potential energy at the same time. Let's think about that for a second. If we get rid of this stuff here, if we pick this object up to this height and then drop it from this height, right here it's got some potential energy, and if we're holding it, it's got no kinetic energy. Then if we drop it, it starts to fall. As it's falling, its height above the floor continually decreases. So potential energy is getting less and less as it goes down to the floor. I drew down arrows to show that it's decreasing. But at the same time, the reason it's falling down is because gravity is pulling downward on it, causing it to accelerate. So on its way down, it's getting faster and faster. If it's getting faster and faster, then the kinetic energy is going higher and higher. Okay? What we're going to figure out is that any potential energy that gets lost turns into kinetic energy. And the sum of these two things is always equal to whatever it started out with. That's going to come a little later on. So the total of potential and kinetic energy, if you add those together, is called mechanical energy. What we talked about a little bit before was is called the work energy theorem, and that's the fact that any change in an object's energy is equal to the work done on the object. So any work that gets done on the object can either change the object's kinetic energy or it could change the object's potential energy, depending on the situation, what you're doing. If you're taking an object and lifting it from one spot to another, then you're changing its potential energy. And its change in potential energy would be equal to the work done on it. If you push on something and cause it to start moving, whatever work you do on it, force times the distance that you push through, would be equal to its change in kinetic energy. So, if the work done on the object is positive, then its kinetic energy or potential energy is going to increase. If the work done on the object is negative, then its kinetic or potential energy is going to decrease. So, for example, if you lift something up, it now has more height, and so its potential energy has increased. If you set something down, you've decreased its height above the reference level, causing its potential energy to decrease. If something is moving, or even if it's not moving, and you give it a shove, apply a force through a distance, it's going to cause it to start moving, changes its velocity. And that changes its kinetic energy. Would cause its kinetic energy to increase. If an object is already moving with some velocity, and you apply a force backward against it through some distance, well, that's going to cause it to decrease, slow down, which would decrease its kinetic energy. So positive work increases the energy, either potential or kinetic. Negative work would decrease the energy, potential or kinetic. All right, we will look at these example problems in class. So that's all we've got for this time. We'll see you later.